Hello, everyone, and thank you for attending. I'm going to talk about the top 10 things to know about machine learning. My name is Carlos Bassi. I'm a managing partner with DataLear. At DataLear, we do advanced analytics, data science, and data engineering to help companies improve their performance. I've divided up this presentation into two sections, part one and part two. Today in part one, we're going to hear the first five things of the top 10 to know about machine learning. Number one is that machine learning is not a replacement for humans. Machine learning is essentially used uh, as decision support to determine other courses of action or to take action in certain processes. For example, we may use machine learning to do patient diagnosis, but that's just part of the input a doctor may get to make a broader diagnosis or a broader decision. We may determine that certain customers are going to churn, leave our service, but that data will then be fed into other processes where other actions can be taken. And machine learning is obviously used in places like fraud detection, compliance, anomaly detection, and always in those cases as decision support, a way to support other decisions and processes being performed. Are there jobs at risk? There's jobs that will change, definitely. Computing and computing power has changed many jobs, and this is no exception. Um, you see people working on driverless cars, and that could affect people who drive, like taxi drivers. Certainly, farmers and other types of occupations have already been changed by this, and many statistical or numbers-driven organizations, such as insurance companies and banks and financial analysts, will also be affected. But mostly, they'll be impacted in such a way where the jobs will change, and not necessarily will these jobs go away, but many jobs will change. In fact, jobs that aren't listed here will change. Number two is machine learning, artificial intelligence, and deep learning are not the same thing. And often we hear these terms used interchangeably. So what's the difference? In my view, machine learning is the technology that automatically finds patterns in your data and uses them to make predictions for new data points as they become available. The difference between that and deep learning is that machine learning has a human interaction to determine the features of a set of data before building models, machine learning models. And deep learning uses a technique where it can determine what those features are. So it removes that human interaction from its processes. On the other hand, they can come up with similar results. I can show it an image, and they can each determine, do I have a car or don't I have a car? The difference is deep learning requires a lot more computing power generally than traditional machine learning. What's artificial intelligence? Well, artificial intelligence is anything that makes us think there's human intelligence involved, or it's human-like computing. That can be caused by machine learning, deep learning, or even an expert system, which is a way of trying to mimic what an expert might do in a certain situation, and might look intelligent to us. Number three, machine learning is easy to understand. Just to clarify, people have been using machine learning for years, even before it got to be cool in the last several years, and got a lot of hype in the press and other places. But machine learning can't generate intelligence, and it can't really learn by itself. We need some people interaction. We need people to present data to models that then, in certain ways, that those models can be built by finding patterns, and then humans have to put those models to use. It doesn't necessarily have to be sophisticated algorithms. Some machine learning algorithms are extremely sophisticated, but some are basically built upon standard statistical techniques that we learned in college and in school. But machine learning can be very valuable when you need to decipher hard to understand data, large amounts of data, and try to determine the relationships among that data can be very difficult for humans to do. Good thing is machine learning skills are trainable. There's kind of a threshold we've reached now where we've had a traditional technique for doing machine learning, which was using a lot of open source tools. We had algorithms in those open source tools. It took a long time to turn things around. It was the data sets were limited, often limited to what ran on a desktop machine or a laptop. But modern machine learning now has become much more robust. Much larger data sets can be used. The library of algorithms is huge, whether it's open source R, Python, or other places. Um, we're also much more robust and scalable because of the cloud. The cloud allows us to scale up in ways that we couldn't do before. Before, where I was maybe limited to only using my laptop, now I can spin up 100 servers and run machine learning algorithms there. And but there's still a need for data prep and deployment, and it can be expensive. So, but still, we're in this new threshold of machine learning. Then that's one of the reasons we see it and hear about it being deployed much more. Machine learning falls typically into four different types of algorithms, or four different types of algorithms are used: classification, clustering, regression, and association. Classifications may be the one we're most used to, where we want to classify something into a category, a binary value, a yes or a no, true or false, a good, bad, or indifferent. So, for example, if I want my machine learning algorithm to tell me whether my customer is going to leave or stay with my service, I could classify that customer into one of two values, a yes or a no. If I wanted to classify my customers into four classifications of premium customers or standard customers, that sort of thing, I could use that type of algorithm. Or is something fraud or is it not fraud? And in all those situations, I'm classifying. So that's typically the most common use of machine learning algorithms. There's also another thing happening today where we see a lot of commodity machine learning algorithms and models, machine learning models available. For example, if I need to perform translation services from English to Spanish, I can use a model that's been built by one of the major cloud providers like Google or Amazon or Microsoft. I don't have to build it myself. I'm not getting a competitive advantage from it. I just need to do it as part of the operations of my business. And everybody else who needs to do translation can use it as well. We don't need to develop our own. It would be very complicated, very expensive, and difficult to do. So we might as well use something off the shelf. Same thing with converting text to speech, speech to text, things like that. On the other hand, there are strategic machine learning models that give companies and organizations competitive advantages. They would be unique to your industry or organization. They're action-oriented. They improve your decision-making, and they're proprietary. They're built in ways that your competitors don't know, and they would tend to give you a competitive advantage. If I could determine whether a customer is going to leave or stay better than my competition, then I have a leg up on them. Then there's also predictive analytics, and again, comparing machine learning to predictive analytics. Predictive analytics uses machine learning mostly, or a lot of times, and it uses it to discover predictive information. It creates statistical models that can generate predictive results, and can be deployed within applications, reports, and other things that are used by ordinary people. Often we can accomplish this with traditional statistical techniques, but most often now we're using machine learning algorithms to build predictive analytics. Number 4, machine learning is old wine in a new bottle, not the new kid on the block. Machine learning is basically a field of applied math. The theory and techniques were often developed even before computers were ubiquitous. We've often just lacked the computing power. In fact, in the early days of computing, there was a belief that many of these problems would be solved early on, but didn't realize that the computing power would still not be enough to solve many of the problems we can solve today. So now we have that computing power, and now that we do, more organizations are seeking to get that competitive edge by finding those complex patterns in data. Machine learning is rated here on this Gartner chart graph as at least as of July 2017 of having been in the peak of inflated expectations, which means there was a lot of hype around machine learning, a lot about what it could do, couldn't do, and it seemed like it could solve everybody's problems. That's often new technologies kind of taper off, and they ultimately get to the right-hand side of this chart, which is a plateau of productivity, which is where I think machine learning is today, where we can actually use machine learning in real ways to solve real problems and get significant solutions done, whereas we couldn't do that before. You also see that there will be a lot of money spent on artificial intelligence. By 2025, $90 billion in the world will be spent on it. So it's a market that companies and organizations will look to use. It's a technology that companies will look to use to improve their bottom line, their revenues, and their competitive edge. This is a chart that also shows where companies are today that are adopters of artificial intelligence, and as you can see here, they're way ahead of companies that don't adopt artificial intelligence or that partially adopt. In fact, companies that partially adopt that are almost no better off than non-adopters. But companies that have thrown themselves completely behind AI definitely see a productivity gain and a revenue gain, and certainly a higher profit margin by using it and depending on it. Here at DataAlert, we've used machine learning to forecast oil and gas production. We've integrated it in applications to forecast future demand. We've developed interfaces that put it in the hands of people who are not data scientists but need to see this data and use it, and make the big decisions, big financial decisions based on it. And we've implemented an architecture that operationalizes it and supports it as their data grows. We've also implemented natural language processing at one of the nation's top security firms, who uses it to determine whether resumes match up with candidates, or candidates' resumes match up with job postings and ads. And we analyze the language in each to see how good or how much of a mismatch there might be between a candidate and a job ad. Number 5, cloud computing is a blessing for machine learning. Again, just to be clear about what we've talked about, machine learning thrives by using powerful on-demand compute capacity. This means it needs a lot of computing power to solve a lot of the problems out there. I can solve some small problems without that computing power, but many of the problems we talked about, translation services, really accurate translation, requires a large computing power, and many of the problems we want to solve require that power as well. Nowadays with the cloud, we can capture much more data, we can analyze much more data, and we can develop some of these solutions that we couldn't do before. And then we can also leverage the API-driven pre-trained commodity machine learning services to help us with what we're doing. Cloud services like AWS, Google, and Microsoft and others have models, that off-the-shelf models that I talked about, that we can use. For example, this is a snapshot of some of the AWS services that I can use. I can use one of their APIs to translate text from one language to another, almost any language to any other. And again, I can use that in a way that's not necessarily strategic to my business, but just something I might need to do. I can also use their video recognition analysis that they built using deep learning techniques, or their image recognition, and other things like that. So I can actually leverage pre-built models that are common to many of us, and we can get a lot of value out of that. Well, thank you for attending the top 10 things to know about machine learning. Next video, I will cover the next 5 things of the top 10, the last 5, and hopefully complete the top 10 things. Thank you very much for attending, and I'll see you next time.